There are lots of different ways to store digital information. For example, flash drives, hard drives, and RAM. These data types are usually arranged in a sort of memory hierarchy with smaller, faster memory at the top and slower, larger memory towards the bottom. At the top of the memory hierarchy are the CPU RAM caches, which are usually built directly into the CPU itself. Next is what is called the main memory, a separate, larger section of RAM that is usually what people refer to when they say RAM. Beyond that, you have the larger, more permanent forms of memory, like hard drives, flash drives, CDs, DVDs, and more. The focus of this video is on RAM, or random access memory. RAM is made so that you can access any random section of the memory at identical speeds. This differs from other devices, like hard drives, which must take time to advance to specific points on the disk. The integrated circuit RAM chips, as we know them today, came out around the early 1970s. Before that, there were other forms of random access memory, such as the William cathode ray tube. There are two main types of RAM, most commonly used today: DRAM, which stands for Dynamic Random Access Memory, and SRAM, or Static Random Access Memory. Both SRAM and DRAM are volatile, meaning that they only store their data while the chips are powered up. As soon as the power is disconnected, the data discharges from the device and any and all information is lost. DRAM is nice because it is very cheap and space efficient. It only requires one transistor and one capacitor per cell, allowing the cells to be efficiently packed together to achieve a higher memory density. In contrast, SRAM usually requires around 6 transistors per cell. These transistors, while making SRAM less space efficient and more costly, also increase the speed and reduce the static power cost of the device. The DRAM cell, unlike the SRAM cell, suffers from current leakage from the capacitor through the transistor. This necessitates the periodic refresh of all the data in the memory, which slows down the device. The advantages and disadvantages of these two types of memory are useful in different memory applications. For example, a form of SRAM is commonly used when memory is built directly into chips, like the CPU. The larger main memory portions of a computer system are usually a form of DRAM, since this is cheaper and more compact. Now we'll take a look at how RAM cells are connected together and used. When you look at a chunk of DRAM memory, you'll see that each transistor capacitor cell is connected to the other cell by row-column wires, known as bit line and word lines. Each cell in the main memory stores exactly one bit of data: a 0 when the capacitor is uncharged, and a 1 when the capacitor is charged. The transistor acts like a switch for the capacitor. When the word line for a specific cell is activated, the transistor connects the capacitors to the bit lines, and the data is sent down the bit lines to their destination. Since reading data from DRAM is a destructive read, the data must be written back to the cells after reading. This is usually done by the circuit itself. Using a sense amplifier in a feedback loop, the sense amplifier compares the bit line to the halfway point between a logical 0 and a logical 1 and amplifies the difference. Since the output of the sense amplifier is connected to both the data output and the bit line, while the data is being read, the sense amplifier can recharge each of the capacitors back to their previous data state. This is also what happens whenever the memory needs to be refreshed because of current leakage. For write operation, the sense amplifiers are disconnected from the bit lines, and the bit lines are connected directly to the data input, allowing the input to directly charge or discharge the selected capacitors as necessary. If you're looking for an alternative to DRAM that is faster, SRAM may be the type of memory for you, or this optimization has its own ramifications. The main difference between DRAM and SRAM is the structure of each cell. While DRAM only requires one transistor and one capacitor to store memory, the SRAM cell generally requires 6 transistors. For this reason, SRAM is typically higher priced than a smaller and more compact DRAM, but in return, it's faster and more power efficient. A large portion of this power efficiency boost comes from the fact that SRAM, unlike DRAM, does not leak its charge, so it does not need to be constantly refreshed. SRAM and DRAM are not the only types of random access memory out there. There are in fact many types. As an example, there's one type of RAM called Ferroelectric Ram, or FE-RAM. Here you can see an example of what a DRAM cell might look like, with the capacitor section here and the transistor section here. With the normal dielectric in the capacitor of the DRAM cell, the polarization is linear, with the E field across the dielectric. This graph basically shows that as the E field across the dielectric changes, the amount of polarization across the dielectric will do the same, meaning for a large positive E field, there will be a large positive polarization in the dielectric. However, if we replace the normal dielectric in the capacitor with a ferroelectric layer, the relationship is no longer linear. Instead, it takes a large enough E field in either direction to reverse the polarization of the ferroelectric. This non-linear relationship in the ferroelectric cell is known as a hysteresis loop. For ferroelectrics, this means that once a polarization is applied, the ferroelectric will maintain that polarization, even after the E field has stopped. This allows the capacitor to store its charge for much longer, meaning that the data no longer has to be refreshed like it does in DRAM. Because FE-RAM is non-volatile, it serves as an alternative to flash memory. It is faster, more energy efficient, and it has a greater lifetime than flash, but is less dense, costs more, and has a destructive read process like DRAM. Well, that's about it. Out of all the different types of memory, RAM is important in achieving higher computation speeds. There are many different types of RAM, like SRAM, DRAM, and FE-RAM, which all serve different purposes in a computer system. Thanks for listening. In return for your time, here's the sound of Logan eating an apple.